In this video, we're going to look at the idea of scaling vectors. Let's start with a vector u, and let's say u looks like this. We'll see if we can draw the vectors 3u and let's say negative 2u. So we're practicing multiplying a vector by a scalar. Well, 3u is going to be 3 times the length of u in the same direction. So I would say that would look roughly like this. Should be exactly 3 times the length of the original vector u here in the same direction. And the vector negative 2u is going to have length 2 times the original vector u, but it will now be facing in the opposite direction. So I would say it would look roughly something like this. Again, its length should be exactly twice the length of the original vector u, and it should be pointing in exactly the opposite direction. The direction reverses because we've got a negative coefficient in this case. So to summarize, when we multiply a vector by a scalar, we get a new vector that is parallel to the original vector. Let's try an example. We're going to find a vector w of length 7 in the same direction as the vector v, which is 3, negative 1, 4. Let's start by calculating the length of the vector v. This is sometimes also called the norm of the vector v, and symbolically it is written like this. So the length is calculated by taking the square root of the following expression. So we've got the square root of 3 squared plus negative 1 all squared plus 4 squared. That gives us the square root of 26. Now the vector w that we're looking for is going to be a scalar multiple of the original vector v. So it's going to be some number times v. We know that because we want w to be in the same direction as v. So what we need to do is adjust the length of w so that it's got length 7. The vector v, we said, had length root 26. So what we need to do is take 7 over root 26 times our original vector v to get a vector that goes in the same direction as v and which now has length 7. So to write down our final answer here, or to rationalize your answer, you could call it 7 root 26 over 26 times the original vector v. Now if you want to see a geometric description of how we arrived at this multiple 7 over root 26, let's think about taking the original vector v, which we said had length root 26. If we took 1 over root 26 times that vector, what we've now got is a vector of length 1, because we have effectively divided the length by root 26. So we've now created a vector of length 1. You could then multiply that vector by any scalar that you like to adjust its length. So if we then multiply that by 7, we've got 7 over root 26 v. That gives us a vector which is now 7 units long. So in fact, that's just going to be a little bit longer than the original vector v in that same direction.